Now I'm doing these examples in a slightly different order from the textbook, just to reinforce that trick about what happens at the extremities. Here is an example with a quadratic in the numerator and a quadratic in the denominator. First, let's try to simplify. Common factor on top of 2, x squared plus 1. Common factor on the bottom. Well, actually, this is a quadratic. How do I factorise that? I need a number that adds to 2 and multiplies to negative 3. Well, that means I must have 3 and 1. So I'm going to have 3 and negative 1. So that means I've got x plus 3, x minus 1. Okay, there's no common factors top and bottom. Ideas. Intercepts. For the y-intercept, set x equal to 0. Well, let's have a look. Y equals, that's 0 plus 2 over 0 plus 0 minus 3. I've got negative 2/3. For x-intercepts, set y equal to 0. Okay, I'm going to take the simplified version. 2x squared plus 1 over x plus 3, x minus 1. Well, if the fraction is equal to 0, then the top of the fraction must be 0. But the only way this can be 0 is if this bit in brackets is 0, because 2 is never 0. But x squared plus 1 is a parabola, that graphs like this. It will never actually get to 0. So that's never going to happen. Not possible. That means my graph does not cross the x-intercept. Does not cross the x-axis. Okay. Intercepts. Discontinuities. Where is this graph discontinuous? Well, it's discontinuous anywhere the bottom is 0. Discontinuous where, I'm going to use the simplified one because it's going to be easier, x plus 3, x minus 1 equals 0. Now you see why we spent so long in year 10 factorising quadratics. That's equal to 0 when x is negative 3 or when x is 1. So there are two vertical asymptotes. This is a little bit trickier to try to figure out what the shape of the graph is. And it really is easiest just to substitute some points. We do have to be a little bit careful about how far away we go from these points, from these values. So let's explore it carefully. My graph's going to look a bit like this. There's two vertical asymptotes, negative 3 and 1. What's happening either side? Well, let's go here, negative 3.1. Let me go at negative 3.1. Maybe I should write it slightly differently. X equals negative 3.1 gives me y equals. So on top, that's squared. This is always going to be positive. Remember what we decided here, the top's always going to be positive. On the bottom, negative 3.1 is going to make this bit negative and this bit also negative. So I've got positive over negative times negative, which is positive. Y is greater than 0. So I'm up here. if x is between the two, well, we've actually got a point between the two, haven't we? But I do still, because of what's coming, so there's a horizontal asymptote in the middle, and I need to know when it crosses. Remember, I warned you this was coming. So I do actually want to find out on either side. Let's go negative 2.9. At negative 2.9, again, the top is positive. This is now going to be positive, but this is going to be negative. So I'm going to have a negative value here. Y is less than 0. Let's put in almost at 1, 0.9. What's going to happen to y? Top is positive. That's going to be positive. 0.9 minus 1, that's going to be negative. So the graph is actually down here. And finally, when x equals 1.1, just to the right of this asymptote, top's positive, that's positive. This is now also going to be positive. 1.1 minus 1 is positive. So I'm going to have all positive, and I'm going to have the graph coming here. That's the basic shape of my graph. It's going to look something like this, like this. But there is a trick coming. Be careful. Discontinuities, let's look at extremities. As x approaches plus or minus infinity, what happens? Well, remember our trick. I've got two polynomials here. I'm just going to copy them down again. Y is 2x squared plus 2 over x squared plus 2x minus 3. If I divide throughout by the highest power of x, which is x squared, I'm going to get 2 plus 2 on x. No, over x squared I'm dividing by. I'm going to get 1 plus 2 on x minus 3 on x squared. And all of these three terms here are going to get close to 0 as x gets very large, positive or negative. They're going to get very large, very small. So I'm left with the leading coefficients, 2 over 1, which is 2. So that is a horizontal asymptote. Now, the trick is that the function itself actually crosses this asymptote. Now that may be a new idea to you. You may have been taught or may have just decided that asymptotes were lines that the function never actually touches. Not true. It never touches it at the extremities. Up here, down there, or out here and out there. But it might cross them in the middle. Let me show you what happens and how to figure that out. So what I want to find out is, are there any points where this function crosses the asymptote? And the simplest way to do that is to make the value of the function equal to the value at the asymptote. Like this. The value of the function equals 2. Well, that means 2x squared plus 2x minus 3 equals 2x squared plus 2. Expand the brackets, 2x squared plus 4x minus 6 equals 2x squared plus 2. These are the same. What have I got left? 4x equals 2 plus 6 is 8, and x equals 2. So at x equals 2, the function value is 2. So, graph crosses the horizontal asymptote at 2, 2. And that's going to help us turn our basic idea of the graph into a neat graph carefully. Let's try sketching it.